Okay, so welcome back everyone, and we will be having a look on the SDA access, which is powered by the DNA Center. This is a continuation class to the last class which we had on Saturday, and what we will be covering is as below. We will be having a look in detail about the fabric roles which we discussed last week. We will be having a look at the platforms, the hardware platforms which will support these type of fabric roles. As we discussed that the Catalyst 9K family is designated for implementing SD access. On top of that, there are few models with which, if you have certain type of soup cards replaced, you can use them as well. If you have an older hardware already running on your infrastructure, we'll see at some of the fabric constructs what are those concepts and why those are important in SD access fabric. Lastly, we'll wrap it with the control plane, how it works using the LISP protocol, and the data plane, how it works using the VXLAN rather than the VLAN in the traditional network. Yep, you all know me already, so I don't think so the introduction is necessary. Okay, so fabric roles. Now, as everyone saw last time, we know that it's the DNA center, the main brain of this SDXS fabric. Eyes for the policy part. Then you have the border nodes for the connectivity to the external world. You have the control plane node, the fabric enabled WLC, and the edge nodes. Also, the fabric access points, which directly register with or form a cap web tunnel, same as the traditional thing. And also, VXLAN tunnel will be having a look at detail on all of this. So, what exactly is a fabric? So, fabric is nothing but a overlay. Stress on this word. Now, what is an overlay? It's a logical topology, not the physical one. It's the logical built on top of physical. So if you look at the diagram, this is called as the underlay, which means that the connectivity part, the physical connectivity part, and the end-to-end reachability part is taken care by the underlay. But an overlay network, it uses an alternative forwarding attributes. Now, what does this mean? Now, you guys must be familiar with GRE or IPsec. These protocols are very widely used in the VPN part. So, even if these nodes are connected to each other on a point to point, or you can say hop by hop basis, still, when in the overlay, it looks like when you are connected here, if your endpoint is connected over here, and here it's the internet. If you want to go out, so when you are connected on the overlay network, this is the overlay part. When you're connected on the overlay, it seems like it's just one hop for going out. You don't see these hops, this one, two. You don't see this thing. You directly see the external entity which exits, or the router which sits at the exit point, and then you exit directly to the internet. So this is what overlay is. Now LISP or MPLS, GRE, IPsec, or even CapWeb, everything is an overlay network. CapWeb, everyone is aware of the wireless part. CapWeb is the access point registers with the wireless controller using this specific protocol. So even if there are multiple hops in between, now if there is access point somewhere here and the wireless controller is connected to this or this specific L3 switch, it will directly form a tunnel like this. So it will look like the AP is directly connecting to the wireless controller rather than going through these hops. So this is what a overlay looks like, or this is what an overlay is. Clear? So if you see, the edge device is here. This arrows are the underlay control plane, not only the control plane but the underlay control plane, which uses any protocol supported as of now in Cisco SD access. There are two protocols supported for building the underlay. Underlay is nothing but the basic connectivity and the reachability using any routing protocol which is supported. And for now, the recommended and the most easiest one is ISIS, and also OSPF is also supported. You can use it as well, but the recommended is ISS because ISS forms a point to point connectivity, intermediate system to intermediate system. It forms a point to point connectivity between every hop, and it has the capability to even work on the like the L2 layer stack. So this is the reason Cisco recommends ISS. And on top of that, a overlay network is built, and using the encapsulation, the data transfer happens. This is underlay, like your original network, you can say the connectivity part, and this is the overlay where actually the traffic flows. Now there are two options to build underlay. We are going step by step because the first part in building SDA fabric is we need to have the devices connectivity in place. Without the devices connected to each other, it's of no use, because if the reachability is not there, we can't do anything without the reachability. So the two methods are manual underlay and LAN automation, popularly known as PNP, plug and play. Might be familiar with this in the SD-WAN as well, because this PNP feature is used in SD-WAN as well to automate the process of like configuration, the vanilla configuration. So the advantage in manual underlays, you can reuse your existing IP network as the fabric underlay. Now, as I discussed, if you already have this specific connectivity running a traditional network, you can straight away reuse it and then directly form a overlay which will connect these devices. Seem like a point to point thing, but it will go through this underlay network. So the relying network would be actually the underlay, but it will look like you are actually connected via the overlay on a hop basis, on a single hop basis. Anywhere you go, it's a single hop. So if a client is connected here and you are connected here and we need communication between this, it will be look like a single hop. But in actual reality, it will all traverse this way. Now, the key requirements for manual underlays, you need to keep it IP reachability from edge to edge and from edge to border and control plane mode. So this has to be reachable by this anyways, either this way or this way. Anything is okay. Now, as we discussed, can be L2 or L3. Recommended is L3, but again, the IGP protocol recommended is ISS because in case of any failure, we still have ISS supporting L2 as well. Just we need to consider that the fabric header will add 50 bytes of additional data, so the MTU size has to be 1500, and the latency should be less than or equal to 100 milliseconds. Now within a LAN network, I don't think so that's a problem, because in LAN network everything is connected in a single building, so that's not a problem when it comes to LAN network. And I think like this is the preferred method because you get to configure using your own way. You don't have to depend on the plug and play part. Yes, plug and play will perform the automation which will be helpful for you, which will save a lot of time, but again, for using that, you need to keep various you need to have everything in place, and there are like prerequisites for it. So if you see, LAN automation is fully automated IP network underlay provisioning, wherein this thing will also be done using the LAN automation or the plug and play. But the thing is, you can do this thing only when these devices are completely new. You don't have, it is known as untouched. These devices should be untouched. You just need to connect it and boot it. That's it. You don't have to access the CLAN. You should not perform any changes. Excuse me. Now, the requirement is it leverages standard PNP for bootstrap. It assumes that the configuration is new, or either you have to erase the complete device and make it to the factory default settings as it was like it shipped newly. And it uses a global underlay address pool. We will be discussing in the design section that what are different IP pools. Now the key consideration is seed device pre-setup is required. This we need to do from the DNA center, and it is 100% prescriptive. That is, everything is scripted. You have to just plug in and that's it. But again, as I discussed, this comes with all these prerequisites. Untouched part. So better prefer underlay, and later on when you know the exact traffic flow, how it works, then we can perform the LAN automation later on. You can perform this LAN automation on a device to device basis as well. Like you can form this using manual underlay and depend on this using LAN automation. Like whatever is feasible in our situation, we can follow that. So this is all about the underlay and overlay, the manual underlay and the LAN automation underlay part. Now we will have, let's discuss in detail about the nodes which we discussed in the last class. We just had an overview kind of thing. I know it might be a bit advanced for everyone, but today we have a brief discussion on that so that everyone is clear with these concepts, because these are the important terms when it comes to SDA fabric. Now control plane node, which is the map database. It runs a host tracking database to store and map the location information for every endpoint connected to the edge nodes. So it's a simple host database that maps endpoint IDs. So the endpoints are identified on the basis of endpoint IDs to a current location along with other attributes. Now, what is the location for this endpoint? So the MAC or the IP would be its endpoint ID, and this switch IP would be the current location of this specific endpoint connect. The host database supports multiple types of endpoint ID lookup types. So it will be either MAC or IP or even IPv6. So everything, all these types of lookup are supported on the control plane node. Now it receives the endpoint ID map registrations from the edge or border nodes for known IP prefixes. Keep this in mind. This entire cloud thing inside is a known network. We don't have anything unknown inside. So what happens is, consider I am connecting my laptop over here on this specific edge node. Let's call it as edge 1. So whenever I plug in my laptop either wirelessly or wired, let's consider the example of wired for better understanding. So if I am connected using the wired media, what happens when I connect to the edge 1? What edge 1 does is it updates control plane node, and this is known as map request. We have a detailed diagram later on, but just for better understanding now, I'm letting you know this earlier. It's known as map request. In this edge node informs control plane node that I have a endpoint with this MAC address, whatever the MAC address or IP would be, and connected to me on this specific port link. For example, port 22, the physical port. So what control plane does is it updates its database that yes, on this specific age one, we have a new device with this specific IP and IP address, MAC and IP address. And it has the capability like we discussed. It's very similar to the DNS lookup or the DNS resolution. So it resolves lookup requests from edge or border nodes to locate destination endpoint IDs. This is nothing but the endpoint ID. Clear? So in DNS center, this is how the fabric looks like, and to assign the role you have to right click on this or just click on it and assign the role of control plane node. In the lab section we'll see later on that how we can assign different roles. So this is how a control plane node is assigned its role, and when it is assigned you can see a small CP is visible on the head of this blue fabric device. Whenever it is blue, it means it is part of fabric, and whenever it is like in a gray, it's connected but not yet assigned the role.
Pranav, quick question.
Yep.
This is Saurabh. So
Mhm.
assigning the role means we are just assigning them as edge or border, right?
Yes, exactly. Edge, border, or
Okay.
control plane.
Control. Okay.
Edge nodes where the endpoints connect. So these are the edge nodes denoted by an E. E for edge. It's responsible for identifying and authenticating the endpoints. Now, whatever the method is, either it is .1x or Active Directory or just the static, like the local credentials, no one would use this, obviously, spending so much on a network and then not having Active Directory or a AAA server. It wouldn't mean. Now,
I think Pranav, you were on the previous slide. Can you just go back there? I was just looking through. I think you're
okay,
talking about the endpoint nodes on the previous slide, right?
I'm on the edge nodes.
Okay, okay. 1 minute. Now, host database suppose my. I was actually thinking about
Uh-huh.
see endpoint map combination. Imagine. So over here, sir, Pranav. So the question is, so you are telling that every edge node basically gets a location. So location is nothing but your location is your switch ID. Is that what your location
Location
is?
location is nothing but IP address of this specific edge node, and endpoint ID is nothing but the EID or the MAC and IP of the endpoint, not the switch.
That
So
IP could be volatile, right? That could be
yeah,
dynamic,
yeah,
and
yeah.
how
Yes. It could be like anything. If it reconnects and gets a new IP address, still the edge nodes. See what happens. Any new connection, be it like it already has its database updated. Obviously, if it has its database updated, then there is no need to inform control. But if any new endpoint connects, it will first go and update the control plane. So control plane has information like, for example, Pranav is connected using whatever the MAC and IP I have, the IP address which is assigned and the MAC address which my machine has on port 22 of me. Me means edge 1. So this thing We'll update this information in a tabular format.
Okay. So that will be an incremental update. So if there is any change of end node ID or something, it will basically change it and replace it.
Immediate. It's on an immediate basis. The first default task which happens is the control plane is informed. So even if I disconnect from here, still the control plane is informed that a disconnection has happened on this specific port.
So I mean, the communication between the edge node and this, all our edges, V edges, and our V smarts, or for instance, V manage, those were using netconf, right? So what do we use here in the background? How does this communication happen?
Here, as we discussed it is underlay. So the actual communication is happening via underlay, but you can see this only as an overlay. The underlay is just for connecting the devices with each other using IP reachability, just for the sake of IP reachability, so that this overlay what we have built is possible.
Pranav, I guess the question Swami wants to ask that which protocol it uses to communicate to the control.
Oh, the protocol in the overlay, it uses LISP. We have it in the further slides today itself.
Okay.
We'll be covering the LISP part. Yeah.
Okay, LISP. Okay, yeah. Okay, yeah, that's what I want to know. Thanks, Saurabh.
Yeah, we were on the edge nodes. So these are the edge nodes connecting the endpoints. Now in SD fabric, any endpoint connects, it's a directly /32 entry, which means that the specific endpoint ID information is stored and not on the basis of subnet /24 /25 /26. Instead of that, it is treated as an entire, what you can say, just the single host. /32 is nothing but a single host, and /128, this is an IPv6, so it is treated as a single host connecting on this specific edge node. Now it provides an anycast L3 gateway. Keep this in mind, anycast L3 gateway we have in the further slides. We'll look what exactly is anycast L3 gateway and how it is helpful in the mobility part. When if my endpoint is connected here and it moves on here or here, how it will help, we'll discuss on that part, because that's the main reason of the mobility. How is it possible in SDA fabric? And this edge node performs the encapsulation and decapsulation of the data traffic to and from the connected endpoints. So whatever data comes or is exchanged between the endpoints, this is the node, that is the edge node, which does the encapsulation before leaving the network or before leaving this specific edge node. And if any traffic comes to that edge node, this is responsible for the decapsulation. So this is all about the edge node, and in the DNA center, you just need to click on that specific edge node and use this option of add to fabric. So when you do just a add to fabric, or E is visible here, so that when the device is blue, it is a part of fabric. When E is assigned, it means that node is specifically acting as an edge node, which will connect the endpoints only. Now the endpoints will not be visible in this diagram because there are multiple endpoints. That's the reason we can't see the endpoints, but you can see like a kind of diagram is already established that how it is connected. Let's see what a border node is. The border node, as we discussed, it's an entry and exit point for data traffic coming into and out of the fabric. So anything goes out to the internet or to the data center, but it needs to exit the SDA fabric, it will pass through the border node. Border node is responsible for the connectivity to the external world or to the external world within the infrastructure, within the organization. Now there are three types of border nodes. One is internal border, which will connect rest of the company, which means the known networks like the data center or any other branch. So it will connect the rest of the company, also known as the known area or the known networks. Second type is external border, which will connect the outside world, which is the internet, or it will have connectivity to the firewall, the perimeter firewall, and then the firewall will take the traffic outside to the outside world. So this is the external border, you can see denoted by this orange. And there is another option to assign it as both, which means internal as well as external, which means we will just have one single border node. It will be used for the known networks and it will be also used for the unknown networks. Most of the times we use this specific, as I have seen, but if yes, the network expands, you have the freedom of using a dedicated node for both these types.
Pranav, question.
Mhm.
If we have 5 branches at 5 different locations, then all 5 locations should have a border nodes and the edge nodes separately.
Yes, 5 separate campuses or 5 separate sites will have
Yes,
this kind of setup.
5.
Yes.
Okay, so this is strictly to the LAN.
Yes, this is very
Okay.
specific to the LAN. As we
Yes.
discussed, SD access
Yes.
is all about the campus part. So anything
Okay.
connecting outside, the SD access ends there. So different sites you will have, like if you have 5 different offices, that 5 different offices are treated as 5 different sites.
Okay. So all those will have edge, border, and control of their own.
Exactly. So this is the border node, and when you are doing it in the DNA center, it has an option of adding it as border. And when you add it as a border, a B role is assigned, or you can see a B somewhat like this. That specific node is acting as a border node as well. Now the beauty is control plane node, the functionality or the role of control plane node and border node can be assigned to a single device as well. Do you see this option? Add as control plane plus border. Yes, it is possible. The same device acts as the border node for going in and out of the network within the organization, or within the organization as well as outside world, and also acts as the host tracking database, which is the control plane node, which keeps information of all the endpoints connected. Now again, it depends on the utilization, number of users, number of endpoints which are active on the network, and this specific thing will be decided in the network design part, whether to assign a single device both the roles, or you have to keep everything separate, or you want the internal and external border as one device and the control plane as other device. It completely depends on the in during the design section, during the design phase, you need to phase this out, that what exactly the number of endpoints. We will discuss this in the migration approach, that how we can decide on this specific design part, which all devices to use, or based on the network size, what functionality should be collated, what functionality should be separated. Internal border advertises the endpoint to outside but the unknown subnets, which is this, like advertising this information to the data center or to another site, or anything which is in the known network. Example can be data center, wireless controller, internal firewall. Now it exports all internal IP pools to outside using a traditional IP routing protocol, because the fabric ends here. So obviously outside it will be traditional. You can't take this SDA fabric everywhere because it exits the campus. You need to do a traditional routing with this border node only, so that this border node is a part, it establishes a communication with the known networks, and you can send the data traffic in and out.
Just a quick question. So this border node, can we have it as a VH, like in case we are combining the SD access and SD WAN into the solution for the for particular site? Can we have this border node as a VH there?
Yes, we can have it, but the complexity increases because that specific device must be capable of handling the load of the VH as well as the border functionality. So it depends on the design, it depends on the infrastructure, how exactly the traditional network is built, how the SD-WAN network is built. And based on that, you can assign the role. But again, it is recommended to keep this fabric separate, because to manage the utilization, to manage the load, because this already has its assigned role and it's doing its part by managing the in and out traffic.
Okay, so when we say this border node and you want to combine it with SD-WAN, do we need after the border node, do we have an VH there, or how will that come into picture? I'm just curious.
I'll have to check on that part. I'll get back to you in the next session. We'll discuss on this part. A few
Sure,
5-10 minutes discussion on this.
sure.
Just
Thank you.
remind me the next time we meet.
Yeah, no problem.
Thank you.
But Pranav, the second, oh, yeah, go ahead, please.
Yeah, actually, border router will be these are 9000 series equipment, right?
Yes. We have the supported platforms in for the 5-10 slides, that what devices support the border node, what devices support the edge functionality, what supports the control plane role. We have that covered.
So it means it will act as a VH if required. If required.
Yeah.
Okay, fine.
Yeah. And also, this border node is also responsible for the handoff, which already has the VRF and SGT mapping. So now, when this specific endpoint, a specific endpoint connected here, is sending any data for the outside world, or you can say to the data center within the known networks part. So this border is responsible for maintaining the VRF and the SGT when it goes out and comes in, because when it exits, as I told, the SDA fabric ends here.
Yeah, just like service VRF we can define over here.
Yep.
How do you classify known networks? I mean, known network for one branch might be unknown for the other branch, right? How do you classify that? I mean, it is the
But
duty of the
but for one branch, we have this dedicated, what you can say, set of border nodes and unknown networks. Sorry, the border nodes and the control plane node and the edge node. So for the other branch, they will have their own set of devices already defined. So we don't need that specific branch to interfere with this, considering the known networks or the unknown networks. These known networks are basically mostly the data center, which will be the same for this branch as well and for this branch as well, because data center is just one, right?
I believe known network is the internal network used by an organization, which they are using in the.
Yeah, so basically, other than the campus network, what else is the part of
It's unknown.
organization's internal network. It's the data center. Right?
Right. Okay, so if I have to connect to some Office 365 applications, which are basically whitelisted for me, right? So those are known networks only, right? Because I know where to go, right? So are they
Exactly.
classified into?
Yes. So for going to the Office 365, you go from the data center, then you have it hosted on the cloud. Obviously, Office 365 is on the cloud, but the exit point is the data center, because the connectivity or the reachability to the cloud, you make it. Now it depends on the WAN network, how you have defined. Either you have defined that this specific border node or this specific site has its own internet access, or every traffic should go via data center. It depends on that design, how it
Yeah,
is designed.
that is where I was coming to. So basically, we have this concept of DIA that I saw very recently on this thing, right? So there, it is not specific that I have to go to a data center. So that's not
No,
a
it is
known
not
network.
specific, but it depends on your design. So if yours, now I've seen such networks where there are sites who have their own internet links, with a firewall in between. So yes, for it there will be like, it will not be a known network. It will go using this outside border directly to the Office 365 on the cloud. But
Uh,
it again depends on the design, that either you are using this specific site with a dedicated internet link, or you are sending each and every traffic to the data center and then exiting via data center. Depends.
Okay. So basically, each campus should have both known and unknown networks, separate borders. It's not possible that you could use one border node and do a segmentation to have known and unknown in the same thing. It's not possible that way.
One thing is, border, if you assign it just as border, it will treat like, it depends on the configuration. So this known and unknown network, this we are defining that whether the known networks connect and unknown networks connect. So there is an option to assign the role that yes, I have the internet links as well as the data center connecting from the border, so it will act as a anywhere or both internal and external roles. You have to select that specific role. If you think, if you know that in this specific site you don't have an internet link and everything has to be going through the data center, you have the option of just assigning the role of internal. So you have to specify that either it will be internal, either it will be external, or it will be both internal and external, depending on your design, how it is designed for that specific site, whether it has a dedicated link or everything has to go via the data center. We'll be looking at that option when we actually do this border node assigning part, so that you are
Pranab, I
clear.
understood your point. Just a small thing, that a single border can be used for known and unknown both, right?
Yeah. So
Okay.
yes,
Okay.
we already discussed here. There are three types: internal and external, or anywhere, used for both the things. So if you see, internal network is connected. Now if this is an internal border, it is connecting the data center or branch office with this specific site. So this is the internal border connecting the known networks, because data center and branch office are the known networks. It's internal to the organization. External border, also known as gateway of last resort, for any unknown destinations. Now, known networks, as we discussed, it will have a routing already. Like for example, if they have eBGP with the data center, so what we have to do, we have to assign a AS number here to this specific internal part, and a AS number will already be defined for this DC part. We have to just specify it here. But when it is unknown network, you don't identify the IP, either it is a public IP or you don't know where exactly to go. It doesn't even belong to the data center segment. It doesn't even belong to any specific branch. So in that case, the default action will be, it will send it to the external border. This external border will take the decision where exactly to take it. So the configuration has to be done in that perspective, thinking of both the known and unknown networks. An external border connects to the unknown IP subnet outside of the network. Now, if they are known networks, it won't go to the external border. It would go to the internal border. If these are just assigned both the roles, obviously it would come to this router, and depending on the connectivity, it will forward it to either known or unknown or the internet. It exports all external IP pools outside into traditional IP routing protocol. As we discussed, we need to connect it to the data center via any routing protocol, or it has a firewall, and then it goes to the outside world. Keep this thing in mind that it does not import unknown routes. It's a default exit. If any IP is not found by the control plane node, the default exit will be first tried with known networks. If no IP subnet is found in this specific border for the known networks, it will exit via the unknown networks. So this decision is taken based on the subnet or IP or the destination IP. What exactly it is it a public IP, or what the user, where the user exactly wants to go? And again, the VRF and SGT mapping, this border node preserves that specific thing, so that when any traffic comes inside, which was destined for this specific endpoint, the VRF tag and the VRF table is already maintained, so that the whatever the data is coming is maintained to the same VRF, and the SGT tag is also mentioned for the segmentation purpose.
In Fabric, can we make a two node network?
It'll be like not two known networks. It'll be, you can have multiple known networks. Just the thing is, it should be
And
reachable
after,
to the border, the internal
and
border.
after that, we can do the load balancing also.
Yes,
Suppose
load balancing on basis of what? Like for the
uh,
border or the, or I didn't get your question.
suppose we have a two known network, suppose B1 and B2, and some of the user we want they can go through the V1 and B1, and some of the user we want to go through B2. So this type of load balancing we can do it.
Pranav, I believe he's talking about the known border device. So if you have two known border devices, and instead of having one known border device and one unknown border device, if you have two known border device in the same fabric.
Yes. So you mean that this again is an internal border, this specific serve as an internal one, and you have only one for external, or you can have two as well. So do you mean like whether this will load balance?
Some of the user they can go to the B1, some of the user they can go to the B2. Something we can do it. Just
Yeah,
ask
that's
him.
what that load balance is. That's what
Yes,
it's talking about.
that can be possible. It depends on how you design it, whether you want to add two internal borders. But again, it gets more complex because you have two internal borders and one uh, external border, or two external borders. Now, as I said, most commonly this control plane functionality and the border functionality is assigned on a single device, because the tasks which are assigned to these nodes are quite less. So these devices which are used are the Catalyst 9000, which are capable of handling so many concurrent sessions at a single moment of time, that I haven't worked on any such scenario, but yes, it is possible. You can do that part. Just you have to configure the connectivity between these two as well.
Okay, thank you.
Now, what are the unknown networks? Public cloud. Like someone was asking, either it will be Office 365 or it will go to the Zscaler proxy and then go to the Office 365, whatever it is, or it's directly the internet. It will be connected to the external border.
Pranav, when
Go
you
ahead.
configure when you assign a role to a device as a control plane plus border, so that border by default goes to internal, external, or both?
It goes to both. It goes to both. Yes.
Okay.
So this was external border. And if you see, the option which I was talking about is this one. You need to specify either both or only outside or only inside. So this is your internal border. This is external border. And this is both. And we specify AS number for our inside network, like the fabric part, and we have to do the traditional configuration or the border where we will specify the remote AS. So if this is 535 and remote is 65534, you have to do the configuration on this external or this border where you are, or this both, whatever, irrespective of the rule, you have to keep the reachability with the traditional network if you want to do a handoff with the known networks or the unknown networks.
So this border nodes, right? These are basically the Cat9K switches, correct? So
Yes.
these Cat9K switches will in turn be connected to some particular router, right?
Yes, it is known as the fusion router. We have a external connectivity session dedicated for that, wherein we will discuss on the configuration part and in more specific about the fusion router, what a fusion router is, how it connects to the reason I didn't add it into this specific session is it will be, you need to understand first the internal part and then comes the external part, because internal we have the SDA access. So there are much more concepts in the internal part first. So once you are clear with the SDA fabric part, what a fabric is, how the ICE part integrates, then later on we have kept it a separate session.
Okay. Okay. Yeah.
Yeah. Fabric enabled wireless controller. Now, first and foremost, this sits in the known networks, but outside the fabric, it connects the fabric via border. The same thing which I said, it will be via underlay, because everything here outside there is no overlay underlay. So basically, it will be traditional. Fabric enabled access points will connect to the fabric enabled WLC via CapWeb. So if you see this green line, it's nothing but a CapWeb tunnel. Now everyone is aware of what a CapWeb tunnel is. So if you see the same way, this access point can't see anything in between, it just knows that its destination or the next hop is wireless controller. In the same way, a overlay works. Now, fabric enabled access points connect to the edge via VXLAN. So if you see, we have a VXLAN tunnel between the access points and the edge nodes. Today we will be concluding with the VXLAN and LISP part. So we will have a look there that how this thing looks. Also, considering the wireless part, or the day 4 or the fourth session will be dedicated for the wireless part, how you can integrate your existing wireless, or how the wireless works in an SDA fabric. We will have a look on detail on how this thing is enabled and how this thing works. This is just an overview for this, that this fabric enabled APs connect to the edge via VXLAN, and it connects to the wireless controller via the traditional CAP-WAP protocol. Now, the wireless clients, this is an important point. Wireless clients use regular host pools for data traffic and policy. So, any wireless device connected to this wireless access point using wireless medium, it will be treated the same as wired, and the data exchange or the data traffic will be sent to this fabric enabled, or not fabric enabled, the fabric edge node. So this fabric edge node will treat. Now consider this example. This is a access point 1. This is edge 1, and you have a endpoint 1 connected here. So when this thing sends any data, I'm using this symbol just for denoting that it is connected on wireless. When it sends any request to this access point will exchange this traffic with the data traffic. The control traffic is the CAP-WAP. The data traffic is this VXLAN. You can see it here. So it will exchange this traffic with the edge node, and the edge node will treat this traffic same as it will consider as a direct connected wired client. It will go to the control plane, see if it has the destination connected anywhere here, or it is inside in the known network, or it doesn't identify and wants to go to the internet. That decision will be taken later, but this thing you need to understand that it will use the same as it is in wired. And fabric enabled wireless controller register clients with the control plane as well.
Pranav, Deepika here. So fabric enabled WLCs can have APs in Flex Connect mode as well.
Yeah, you
So
can
that would
have it
be
in Flex Connect. Actually, the recommended is in Flex Connect only.
okay. And is there any, I mean, if suppose this fabric enabled WLC is like in a regionalized model, is there any kind of limitation which we have on what device we can use for fabric enabled WLC?
Yes, we
Because
have that specific limitation on which we can enable the fabric enabled functionality. The next part is after this 1 or 2 constructs, we have that model discussion wherein we will see what specific models of the access point, or every role what specific model supports that.
okay.
I know everyone is more curious on knowing the models. Yes, we have it. We have it covered today. Don't worry.
Pranav, I don't understand the last point. What it says, fabric enabled WLC registers clients with a control plane. I mean, I'm not very comfortable with the wireless side of it, so it might take a little.
No problem. So
So what
you
does
can
this?
just relate this specific point with what I said. This edge will treat this wireless client the same as the wired client, because this access point is already forming a VXLAN tunnel with the edge node. So it will look like a data traffic is coming somewhere like here. If there is a communication happening between these two, it will treat this as the same way. Don't think much on the wireless part. Just think that when anything connects on this access point, the same thing will happen as it would happen to a wired client. The same
Okay.
traffic flow happens.
Okay, got it.
Yeah.
And I think somebody in the class was asking about the Flex Connect, right? I've heard about that. What exactly does that mean?
Flex Connect is nothing but a mode wherein you can you assign the access point the role of, or the role of Flex Connect, wherein the data traffic exits locally from this specific network. There are two modes, like more popularly used, local and Flex Connect. I am also not much into the wireless part, but as far as I know, the local is like central. It happens like central authentication and central switching, and Flex Connect is nothing but central authentication, which is authentication in the wireless controller, but the switching will be local, so it'll like exit something like that. If there are any wireless experts we have.
Okay. I think
Yeah.
I'll do some reading there. Okay, no problem. Yeah, thanks.
Yeah. Anycast gateway, we discussed this earlier. We just had this term used. Now, what is Anycast gateway? It's an interesting and a very important term in SDA fabric. Now it provides a single L3 default gateway for IP capable endpoints. What does this mean? Consider I have a SVI. SVI is L3, right? So if I have a SVI of VLAN 3 with the IP address of 3.2.2.1.
That SVI would be your default gateway for all the members in VLAN 3, right?
Yes. So Anycast gateway means this specific SVI is present on all the edge nodes. Now, as far as I know, in the traditional network, you have a SVI on one specific. You basically configure it on the core switch, which is the L3 switch, and everything, the communication with the L3 SVI happens with the core switch. The L2 switches contact the distribution. The distribution contacts the core switch, and then it gets outside using this SVI, or the VLAN switching or the inter VLAN switching with between the SVIs happen on the core switch. But in this case, this specific SVI is present on all the edge nodes, which means if this is the gateway for the endpoints, it is present on all the edge nodes. So no matter where you connect, see, you can see it is very nicely explained with these arrows. If this user gets, one second, if this user moves on to this specific different edge node, then yes, you can use the same. Yeah.
So Pranav, is it like spine type, spine and leaf?
Yes.
Where,
Yes.
yeah.
Yes. So the similar principle and behavior to HSRP VRRP, wherein they have a virtual MAC and virtual IP. So the same switch virtual interface, which is the SVI, is present on every edge for the mobility purpose, so that if the users are switching their location from one floor to another, or one access point to another access point, whatever they are switching, they'll have the same level of experience because of this feature. Because in traditional, if this gateway was present only here, you have to get this to the core switch and then it would get out. But for this, it has on every specific edge node. and control plane with fabric dynamic EID mapping. EID mapping is nothing but the endpoint ID mapping. We saw it that this control plane has a endpoint ID mapping with this specific switch IP. Now let me tell you, this mapping is known as, which is there in the control plane, is known as EID to RLock mapping. EID is the endpoint ID. RLock is nothing but the resource or remote locator, which is IP address of this edge node. So we have to just remember that this control plane maintains the host to edge relationship and the edge to client relationship. So it has everything in its table, the mapping. So when a host moves from edge 1, consider this as edge 1. This is already connected on edge 1. If it moves to edge 2, it does not need to change its default gateway because the gateway is already present.
Only the
So
controller
suppose we have
Yes.
okay. So suppose we have more than one. Like obviously you'll have more than one SVI. So all
Right.
these SVIs are present in every edge node, right?
Yes, you're correct. Every SVI will be present on every edge node.
I mean, this is similar to the VTP mode transparent, right? Where you configure all the VLANs on all of the switches, right?
Yes, but the thing is, you have a SVI created on one specific core switch. Consider VLAN 3. You have this 3.2.2.1 IP on that specific core switch assigned to the VLAN 3 interface or the SVI. But
Right.
here you create it once from the DNA center and it's replicated on everything, and it has a virtual IP and MAC.
So what IP
So if
will
you
each of the switches have? So I mean, will it? Okay, it's a different. Okay, it will have the same virtual IP. Okay, okay.
Yeah,
right, so only the controller mapping will change.
perfect.
The
Only the
yeah.
controller mapping will change when this endpoint goes to a different edge node, but the gateway remains the same. So it will exit from here rather than to transit from here. And this moment will obviously, again, as I told you, if this connects on this specific node, first thing is this will be notified, and yes, it will update in its table the new endpoint ID to RLock mapping. We have that as well, the endpoint RLock mapping. Clear with
Something what the
Anycast gateway?
VXLAN does, right? Something like what VXLAN does.
Yes.
Portability. Okay.
Yes. Stretched subnets, it will allow an IP subnet to be stretched via the overlay. Now, any subnet, we have like the gateway, we have it on all this specific edge nodes. Host IP based traffic arrives on the local fabric and is transferred by the fabric, which means that if there is any specific endpoint connected with the same gateway on this edge 1 and the same gateway or the same VLAN SVI, consider this as VLAN 3 and consider this endpoint is also on VLAN 3. So this information, already the control plane has this information. So it will be a direct communication. The fabric dynamic EID mapping, as I told you, any gate to any specific endpoint connects, it will mention the entry as the /32 IP address rather than the entering the entire subnet. And if it is IPv6, it will be /120. So this makes the mobility part easier in the fabric, and we have a track of everything, that when a specific host moves to another switch, we know, the control plane knows that yes, this specific endpoint is connected to another edge switch and it has disconnected from this specific switch. Host 1 can use the same subnet, even if it is connected on the host 1 can use the same subnet to communicate with the host 2, and you no longer need a VLAN to connect host 1 and 2. It can be a part of same VLAN. The HVIs are present everywhere, so a direct tunnel will be formed for the communication, which will be using the overlay. Just a single hop traffic
So,
flow.
Pranav, if host 1 and 2 are a part of different VLAN and we have two SDIs.
So what will happen? This will query the control plane node. Control plane node already has this specific information. Now, if it is VLAN 4, the SVI is VLAN 4, and this endpoint is on VLAN 3. This control plane will tell this node that the destination you are trying to reach is on RLOC 4 or H4. So this will then form a direct tunnel.
Great, perfect, thanks.
Yep.
Pranav, I have another question. Just comparing it with like SD-WAN. If suppose
Can
we
you
have
be a
100.
little bit loud? I'm not
Okay,
able
can
to
you hear
hear
me
you.
now?
Yeah,
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 can
yeah.
you hear me now?
It's okay now.
Yeah.
Yes.
So I was just comparing this with SD-WAN. So in SD-WAN we just have say two or three vSmart controllers which will be in sync with each other, and that is our control plane, right? That takes all the control plane decisions. Here, if I have 100 sites, then every site needs a control plane node. So where am
Yes.
I actually doing that functionality demarcation, where only I mean, still we have so many points of control plane at each and every site. So, is that centralized in some way?
Yeah, because this configuration, you're not doing it locally. You're doing it via DNA center, right?
Mm-hmm.
You're not doing it by going to the box and then configuring each and every port. You're doing right away from the DNA center. So the centralized part which you're talking about is achieved using DNA center. And all these 100 sites are configured. One second. Sorry for that. Yeah, so all these 100 sites are taken care by the DNA center itself. So any configuration you do on these 100 sites, it's via the DNA center. So everything is centralized, but to keep every site separate, we have this set of devices. Because if you have a single control plane, now as you considering your question, if you have a single control plane node, border node, the edge nodes, what are we achieving? Then there's no term known as site. Everything will be into a single site. It will not be a different site anymore. So this is just a typical SD access network diagram I thought I'll share with you. So I have added this into the slides. If you see, this is the DNA center controller. We have the identity services engine. We have the data center connecting these words to a central node known as Fusion router, which will be covering in the external world connectivity part. It, it has a wireless controller sitting outside the fabric, but is fabric enabled. You have the set of DHCP, DNS, Active Directory, NTP servers, whatever you call it. The fabric border nodes, you have it connecting the entry and exit points of the fabric. You have the brains, the control plane, which has the host to RLOC mapping or the host to edge switch mapping. You can call it in any words. See, the terms are important just for remembering, but the underlying concept or the underlying what exactly happens. The method is important. So even if you call it as host 2 or the endpoint to the edge switch mapping, it is okay, considering you already know what exactly it is and how it exactly works. These are the intermediate nodes which are just a part of underlay and will help connect many edge nodes. If there are many edge nodes and there are not sufficient ports on the fabric border node, that's where we can use an intermediate node only for the underlay to connect these many edge nodes to the border to establish a reachability, IP reachability. And these are the endpoints which connect only to the fabric edge nodes and no other nodes.
Pranav,
Yes.
in this diagram, the control plane and edge. Okay, so if something goes to edge, some user connects or disconnects, and it has to go to the control plane, so it has to go to the border first.
No, the first thing it goes to its control plane node. Control plane node checks in its host database whether the destination which host 1 is trying to reach is present in its database or not. If it is
Absolutely.
present, it will give the IP address of that edge node, after which the edge node will form a direct tunnel. If not, then it is left out with the border.
Okay, so from LISP, it's directly forming a tunnel. I was checking underlay, so underlay it is not connecting, it's coming via border.
No. First, it will check the control plane. Underlay just, I told you, underlay is just for connecting the devices to each other for having the reachability part clear.
Got your point. So it will communicate via LISP, as you said.
Yeah.
Okay.
Now the questions which everyone had about what are the platforms supported in SDA Fabric, which specific role supports which specific device. So let's start with the control plane node. We have the new Catalyst 93,000 series, 94,000 chassis switch, 95,000. You can see 93 supports the RJ45, that is directly the endpoint connectivity, or the RJ45, the normal CAT connectivity. 9400 also has the same thing border. This 9500 models are a bit advanced and have the 40 and 100G capability as well. So mostly either this or this is used because you don't need such a big switch just for the control plane node. So this is the hardware supporting the control plane node. In addition to those, yeah.
Pranav, we have actually 6500 in VSS, and we are planning to replace with 9400. So that's
let me tell you, like 6500 also supports SDA.
Okay.
Just
Pranav, can you just go back one slide? So whatever you showed, those were edge nodes, right?
No, those were control plane nodes. We are not yet on the edge node.
Oh, those are the control plane nodes. Okay, so
Yeah,
these are all
I said, mostly this device is preferred as edge because it has multiple SOAP cards, multiple ports. We don't need this. Yeah.
Right. Yeah. So they're rich on ports, right? Obviously, you don't need that. Okay.
You have the Catalyst 3K, the Catalyst 6000, which is 6500 or 6800, which most of them have in VSS, and most of the networks I've seen this. Even the ISR 4000 series can be used as a control plane node. The ISRV, CSRV can also be used. The ASR 1K, but again, using this device would be okay. But using a chassis is like for the control plane. It depends on your requirement, how expanded your network is. So based on that, you can decide which specific platform to go ahead with. So this was all about control plane nodes. Coming on to the edge nodes where all the endpoints connect, Catalyst 9200, a new addition to the Catalyst family, 9300. This supports control plane as well as edge. Control plane we already discussed. There will be many devices which support all the three functionalities: border, control plane, edge. So don't get confused. Each device is built with that capability. So if you see 9300, you saw it in control plane node as well, right? 95,000, 9500, you saw it in control plane as well. 9400, you saw it in control plane. So all those devices support the edge node functionality as well. Considering every floor has multiple users, wired users connected. So on the projects which I have worked, I've seen like most probably the 9400 is used on most of the floors, but there are situations where there are just 5 to 6 of the endpoints on a small mezzanine floor or a ground floor. Then you can just go ahead with any of the ports, any of the switches which has the least amount of ports. I mean, again, it's on the requirement which you need. What is your requirement? What is the number of endpoints connecting to the network on that specific floor? The Catalyst 3K, the 4500E also supports the edge node functionality. The Catalyst 6K, which is the 6500 and 6800, which is popularly known for this. 6800 is known for this VSS functionality. Yes, you can use that as your edge nodes. Just make sure in 4500 you need to have this specific soup cards to support the uplink to the border nodes. Border node, Catalyst 9300, the same device which supports edge node functionality as well as control plane functionality. 9400, same thing. 9500, same thing. Most probably I have worked on border nodes of 9500 because it has this 10 gig and 25 gig ports, all of these ports, to connect it to the edge nodes. The edge nodes uplink will be connected on this specific border node. So this device mostly suffices the requirement. Not a mandate, just sharing my experience, whatever I have worked on. This was the model used for the border node. These all devices also support the border node. Catalyst 3K, 6K, Nexus 7K. Keep this in mind, it has some specific prerequisites: ISR 4K and ASR 1000. If you go on to the Cisco's website, you can read more about these specific devices in detail, which are the new ones, which all are the old ones, the existing ones. I'm sorry, went directly on the last slide. For the wireless part, yeah, someone was asking me about the wireless part as well. If you see this WLC supports the Air OS, the earlier versions. There is an addition to its family, the 9800, the C9800, which can be hosted even on VMware and AWS. I haven't used this yet on the cloud, but yes, these are specifically used as the WLC, the fabric enabled WLCs, the wave to access points, the 1800, 2800, 3800 series, wave 1, the specific features. So this is about the wireless which supports SD access. For IoT networks, Cisco has a separate product line, the industrial Ethernet, which is the IE series. Now, in earlier session, we saw that there are extended nodes used for connectivity with the for the IoT devices, the cameras, the smart lighting, or even the access points can be connected. Yes, so there are specific extended nodes which connect to the edge nodes and then connect these devices on itself, the smart IoT devices.
So
So
these are all wired. These are all wired, right? What you're talking about here?
yes, yes, yes. These are all
To the
wired.
edge, to the edge nodes, everything is wired, correct?
Yes, everything is wired.
Okay.
Even the access point, it forms a tunnel, treating it as a wired user. Seem like wired user.
Okay. And when you're talking about IoT, I was thinking, what is it still going to be wired, or is it something
Yeah,
else?
it's still gonna be wired. Operational IoT simplicity for IT design and managed. We have a greater visibility because we are assigning this IoT section is a completely different part. It has a separate product line for managing the IoT devices as well. There are the IE controllers who manage this specific IE devices. If you have that specific devices, you can either use it or just put it on the extended nodes, the IoT devices, and use it via the SDA fabric. This is just an extension to the existing nodes.
What is OT managed here? IT designed and OT managed. What does that mean?
OT is something related to IoT. I am also not sure of that. What exactly OT managed is. I'll get back to you on this OT managed because in my entire work history I have just worked on one project which had the IoT part, and it was back in 2016, a smart city project.
So how would you basically differ it from normal wired connectivity? Like how would you explain it if I have to say it in 2 lines? How would the
Yeah,
connectivity be?
so the connective would be a extended node connects to the edge node using L2, and these IoT devices are nothing but like they are not smart devices. They just either it's a camera or a smart lighting or whatever, or a PA controller. It connects to the extended node, and the traffic medium it goes via L2 to this edge node, and from here it's all L3. So you can say that you are adding a legacy edge node or a legacy access switch to this core switch, but this is your edge node in terms of SD fabric.
Okay, and
So
how are the access? How are these IoT endpoints? So do they have like a IP address, MAC address? I mean, how does the control plane register that?
yeah, as far as I've seen, most of the IoT devices directly work on the MAC address basis. So this control plane registers them. This control plane registers them with the MAC address and the RLOC mapping, that it is connected on this RLOC, and later on you know that this RLOC again has a L2 switch connected to itself. And if it has an IP, the IP and MAC address, again the same story from edge node. What it happens, it's the same, just we are, instead of connecting the IoT devices directly on the edge nodes, what we are doing is we are extending this edge node with L2 and then connected these devices so that we have a separate switch for the IoT devices, and some of the IoT devices who don't understand L3 traffic, it will be easy for those kind of devices in the IoT network. So the switches like these small 3560 compact switches, or even the IE4000 or IE3000 series. So the devices which will be used in IoT technologies, like it can be any device. There are n number of IoT devices, and the list is growing day by day. So for an example, you can consider the IP cameras, or the smart lighting system, or the PA controller, or you can say the speaker system, anything which is like not that smart but acts as an IoT device. You can, like, there are multiple devices in the IoT class of devices. Yep.
I mean, these are basically PoE switches only, right? Because they power through the.
Yeah, these are PoE switches, which, like, the cameras, the IP camera, they take power directly from these IE switches. We don't need to specify. Don't need to connect it to any external power connector.
Correct. So these are okay.
We have a question. We can integrate all IoT devices. Don't integrate with the DNA center. There is a specific industrial, I don't remember the name. There is a specific industrial controller where you manage all the IoT devices. That controller, you can integrate it with the DNS center, but I myself don't. I'm not aware of that specific use case, so it's hard for me to tell more on the IoT part. Now, it's a important topic, but the time doesn't permit us to go ahead because it's already 2 hours. We started some 10 minutes late. So what we can do is we can continue this part into the next week, and I'll make sure that all the three planes, like control plane, the data plane, and an additional policy plane which uses Cisco TrustSec. I actually had the plan of covering the control plane and the data plane in this specific session, but the time does not permit us. It's already 2 hours, so we'll add this specific into the next session, and next session I'll try to make it 1 hour longer. So instead of keeping it for 3 hours, I'll make it a bit early so it is easy for you guys, and then we can extend it till 3 hours so that we cover all these planes into a single session.
So Pranav, do we have a session tomorrow?
Tomorrow we have a session wherein we will be having a walkthrough of the DNA center. It will be just kind of a demo session where I'll show you all these terms which we see, which we discussed, how those are implemented in the DNA center. We'll be having a walkthrough on the dcloud DNA center. What are the different roles, how you add the devices, the design section, how you add the different sites, how everything is centrally managed in the DNA center, more familiarity with the DNA center. So that's the agenda for tomorrow. I've not kept any theory for tomorrow because it shouldn't be overwhelming. You'll get to know it, how exactly everyone already has the URL of that specific dcloud, which is available over the internet. So while I'll be walking through, you can check it yourself as well tomorrow. Okay, then. Thank you very much for attending today's session. I hope you learned something new about SD access in today's session, and we'll meet you guys tomorrow in the walkthrough session. We'll look at how a DNA center looks like, what are the different tabs, what are the different options in DNA center. And thank you very much for taking time to attend this. Bye-bye, everyone. Take care.
Thanks, Pranav. Have a nice and safe day.
Yep, you too. Bye.